Hello again, traveler. It's Benji. Tonight we're staying close to home, but we're going to rise slowly into the air that surrounds us, the invisible ocean that wraps our planet. This isn't just nothingness. It's chemistry, motion, memory. It's how you breathe, how you dream, and how Earth stays alive. Let's drift upward and understand the world above, the atmosphere beneath our feet. Chapter 1: What the atmosphere is made of. Right now you're breathing a mix of gases, mostly nitrogen, about 78%, then oxygen, 21%, the rest a whisper of other gases: argon, carbon dioxide, neon, helium, water vapor, and more. Oxygen fuels your cells. Carbon dioxide warms the planet, naturally, gently. And nitrogen? It helps keep oxygen from burning too fast, like a steadying hand on a candle. This balance is ancient, formed over billions of years, fine-tuned by life itself. Chapter 2: The layers above us expanded. Earth's atmosphere isn't a single wall of air. It's layered, like a blanket folded many times over. Each layer has a different personality, a different purpose, a different kind of silence. Let's drift upward now, slowly, from the surface into space. 1. The troposphere. This is the lowest layer, from the ground to about 12 kilometers above sea level. It's where we live, breathe, and watch the weather change. It holds about 75% of the atmosphere's mass and nearly all of its water vapor. This is the layer of clouds, rain, wind, and snow. Thunderstorms form here. So do hurricanes and jet streams. Even Mount Everest barely pokes into its edge. As we rise through the troposphere, the temperature drops roughly 6.5 degrees per kilometer. That's why mountaintops are so cold, even when the valley below bakes in the sun. At the very top is a boundary called the troposphere, a thin, cold ceiling between weather and something else. 2. The stratosphere. Above the troposphere lies the stratosphere, stretching from about 12 to 50 kilometers high. Here the air is dry, calm, and layered, perfect for long-distance flights. Commercial jetliners cruise at this altitude to avoid turbulence, and high-altitude weather balloons float slowly here, sending back data to help us understand storms. The most important thing in this layer? The ozone layer, a thin shield that absorbs most of the sun's harmful ultraviolet radiation. In this layer, the temperature actually increases with altitude. That's unusual, but it happens because ozone absorbs UV light and warms the surrounding air. Without the stratosphere's ozone, life on land would be scorched. The mesosphere. Above the stratosphere, from 50 to 85 kilometers up, we enter the mesosphere, a cold, quiet region where the air is too thin to breathe, but dense enough to burn meteors. Every shooting star you see in the night sky likely disintegrated in this very layer. Temperatures here can drop as low as 90 degrees. It's the coldest layer of the atmosphere. We know the least about the mesosphere. It's too high for planes, too low for satellites, like a secret sky between worlds. At the top of the mesosphere is the mesopause, an invisible line before things heat up again. 4. The thermosphere. From 85 kilometers up to around 600, we enter the thermosphere. Here the sun's energy bombards atoms and molecules, stripping away electrons and creating ionized particles. This charged region is known as the ionosphere, essential for radio communication, satellite signals, and auroras. The northern and southern lights, those dancing veils of green and pink, are born in this layer, created by solar particles colliding with Earth's magnetic field and gases. Temperatures can soar to over 2,000 degrees here, but it wouldn't feel hot because the air is so thin there are hardly any molecules to transfer heat to your skin. This is where the International Space Station orbits, where astronauts float, barely held by Earth's breath. 5. The exosphere. Finally, we reach the exosphere, the edge of Earth's influence. It begins around 600 kilometers above the surface and fades slowly into the vacuum of space. Atoms here are so far apart they can travel hundreds of kilometers without touching each other. There is no clear boundary, just thinning, drifting, letting go. Some hydrogen and helium atoms may escape completely, leaving Earth forever. This is the final whisper of the atmosphere, a gentle fading into the cosmos. From the troposphere to the exosphere, you've just crossed over 600 kilometers of layered, dynamic air, each part serving a purpose, each invisible, yet vital. The sky is not a void, it's a system, a scaffold of life. Chapter 3. Why the atmosphere matters. The atmosphere is essential to life, and not just because it lets us breathe. Here's what it does, and what happens when it's disturbed. 1. Protection from radiation. The sun bombards Earth with harmful ultraviolet UV rays, but thanks to the ozone layer in the stratosphere, most of it is absorbed before it reaches us. When this layer was damaged by human-made chemicals, like CFCs in old aerosols, a hole formed over Antarctica. Skin cancer rates spiked. Crops became more vulnerable to UV damage. But with international action, we've begun healing that layer, a rare win for the planet. 2. Temperature regulation. Without the atmosphere, Earth would be a frozen rock at night and a scorched wasteland by day. Our atmosphere traps heat through a natural process called the greenhouse effect. It's what keeps the planet's average temperature stable. But too much carbon dioxide and methane, and the heat becomes trapped excessively. That's what we're facing now with climate change. Glaciers melt, storms grow stronger, wildfires spread farther. It's not the atmosphere's fault, it's our imbalance of it. 3. Weather and water distribution. The atmosphere moves moisture around the globe. It evaporates ocean water, forms clouds, and returns it as rain or snow. This cycle nourishes crops in India with the monsoon. It fills reservoirs in California. It carries dust from the Sahara across the Atlantic, feeding the Amazon rainforest with ancient minerals. Everything is connected through air. 4. Energy and disasters. Wind is just moving air from high pressure to low. But when heat builds up, this movement can become extreme. Hurricanes, tornadoes, and heat domes are all products of atmospheric imbalance. In 2021, Hurricane Ida drew strength from warm, moist air and devastated parts of Louisiana and the northeastern U.S. These events remind us the atmosphere is powerful and personal. 5. Life support and evolution. 3.5 billion years ago, Earth's early atmosphere lacked oxygen. It was volcanic, toxic, but tiny bacteria evolved to use sunlight, releasing oxygen as a byproduct. Over millions of years, this transformed the air, creating a breathable atmosphere and enabling the rise of complex life. You are breathing the legacy of microbes. You are the product of air made by life. Chapter 4. What we breathe. The air is alive with motion. even when it seems still. Every breath you take exchanges molecules with the past. You may inhale atoms once exhaled by Einstein, or swept off the wings of a monarch butterfly. The same air that holds a whisper can carry pollen, pollution, joy, or disease. During the COVID-19 pandemic, we learned how invisible air truly is, how something we don't see can change everything. Chapter 5: Air in Crisis. As we burn fossil fuels, we add gases into the atmosphere that trap heat. We thin the balance, thicken the warming. Climate change is not just global warming. It's disrupted rainfall, rising seas, stronger storms, and shifts in ecosystems. Our atmosphere is changing, and it's asking us to listen. But it's not too late. The Montreal Protocol helped repair the ozone layer. New innovations are cleaning urban air, and every tree, every wetland, every reduction in emissions makes the air just a little better. Tonight, as you breathe quietly, remember that the sky is not far away. You are inside it. The atmosphere is not above you. It's around you, within you, made by life and keeping life alive. Let your breath slow. Let your body soften, and let the ocean of air hold you gently, as it has held the earth for billions of years. Good night, traveler. This was Benji. Until next time.